Every day we produce tons of waste. Unfortunately, the vast majority of what we throw away ends up in landfill sites. In the Czech Republic, there are around 400 landfill sites in operation. Still more have been sealed up. We have buried a huge amount of problematic and dangerous materials underground. This inheritance for future generations has rightly been called an ecological time bomb. Among the municipal solid waste stored in landfills, a variety of rotting and fermenting processes are also taking place. Viruses, bacteria and other pollutants are multiplying. In order to keep these hazardous substances from getting into the soil and thereby threatening the ecosystem, landfills are lined with impervious films. However, in time these crack and harmful substances leak out into the soil. It is also very difficult to find space for landfills, the establishment of which devalues agricultural land. If we continue down this path, then within a few years we could literally be wading in rubbish. The trend in the European Union is to limit landfills and instead incinerate waste for its own benefit. In the EU, individual states resolve environmental issues together, as this field does not respect political borders. Obviously, incineration does not preclude recycling, because even after sorting recyclable materials, a large quantity of combustible waste remains. A modern incinerator gets rid of waste on the one hand and uses its energetic potential for producing heat and electricity on the other. How does it do this? You will find out in the next few minutes as we introduce the operation of the Liberec municipal waste incinerator of the Termizo stock company. The incinerator is a facility for energy recovery. More specifically, it uses solid municipal waste that would otherwise end up in landfills for heat production. The Termizo facility has an annual capacity of 117,000 tons, which is half of the waste produced in the Liberec region. This capacity is filled without a problem. The annual supply of heat to the central distribution network is 600,000 gigajoules, and the facility also supplies 13,000 megawatt hours of electrical energy to the electricity grid per year. The Termizo Liberec incinerator was put into operation in 1999 and since then has worked without problem. 4 highly qualified workers take care of the running of the facility in continuous shifts. Operation of most technological units is fully automated. The staff carry out surveillance and control of individual parts of the equipment of the incinerator. The system by which the incinerator literally converts waste into electricity and heat can be seen in this diagram. The waste is first stored in the bunker, from where it goes to the furnace, where controlled incineration takes place. The steam generated is piped to the heating plant, and then through the centralized heat supply to individual users in Liberec. In the meantime, the steam is used for the turbine that powers the generator where electricity is produced. This is used for the facility's own needs and further to the energy distribution network. That is how the Termizo incinerator in Liberec works. Let us have a closer look at its technology. Solid municipal waste is taken to the bunker. This is accessed by 5 hydraulically controlled gates. In the bunker, the waste is mixed with the aid of a crane, thereby constantly preparing it for complete combustion. If necessary, large waste is crushed by hydraulic shears. Following the preparation, the crane operator loads the waste into the furnace funnel. As mentioned earlier, the facility can process 117,000 tons of waste per year, meaning that an average of 15 tons per hour go through the funnel. From the funnel, the waste proceeds to the hydraulic feeder, which passes it on to the grid. The waste is burnt on this moving grid. Combustion air is brought to combustion and blown under the grid from the waste bunker by a ventilator and heated with a steam heater. This causes a slight negative pressure in the bunker, reducing odour and dust emissions to the immediate surroundings. Secondary air and recirculated combustion products are brought from combustion to the boiler and blown into the combustion chamber by ventilator. This reduces the amount of combustion products discharged to the atmosphere through the chimney and completes the management of the combustion process. Natural gas is used for waste combustion, and the following combustion process is fully automated. The control system monitors individual combustion parameters and continually evaluates any deviations from the state required. This ensures complete combustion and the high quality of non-combustible cinder and fly ash residues. Burnt cinders contain a maximum of 1.5% carbon, which is proof of very good combustion. The combustion temperature on the grid varies according to performance from 900 to 1100 degrees C. In the burning out zone beyond the combustion chamber, where combustion products remain for 2 seconds, the temperature is between 850 and 1100 degrees C. Energy released during waste combustion is collected in the form of heat and transmitted to the production of steam. The rated performance of steam in the furnace is 43 tons per hour. The steam has a temperature of 400 degrees C and a pressure of 40 bar. This steam is first piped to the back pressure turbine, which has a rated performance of 305 megawatts. Thanks to reduction in the turbine, the parameters are reduced to 230 degrees C and 8 bar. Up to 6,000 megawatt hours of electrical energy enters the electricity grid in this way per year. Steam from the turbines is piped to the district heating system in Liberec. The effective heat supply is approximately 600,000 gigajoules per year. The described process combining the production of thermal and electrical energy is called cogeneration. The efficiency of use of the steam produced is around 80%, which shows the high level of efficiency of the process. If the customer does not use up all the heat produced, the heat is subsequently used in the condensation turbine with a rated performance of 1 megawatt. Part of this electrical energy is used for our own needs, that is, for the running of the facility. The rest is supplied to the energy grid. As well as high energy efficiency, a strong emphasis is placed on ecology in the Liberec incinerator. Resulting combustion products are cleaned, as is the water used, and fly ash with cinders. For these reasons, electricity produced in incinerators is generally among the cleanest forms of energy. First, we will acquaint you with the process of flue gas cleaning. There are very strict emission limits on combustion waste. In order to achieve these limits, 4 degrees of flue gas cleaning have been installed in the incinerator. These are the reduction of nitrogen oxide, fly ash capture, the capture of dioxins and wet flue gas cleaning. Nitrogen oxide reduction in the incinerator takes place directly in the combustion chamber, which is administered with 25% ammonia water solution. Subsequently, the so-called selective, non-catalytic reduction of nitrogen oxides is carried out. Fly ash contained in the flue gas is captured by electrostatic means. From the spoils of its lower part, it is transported to the ash silo for further treatment. The remaining part of the fly ash is captured by catalytic textile filter, the main purpose of which is to degrade dioxins. Dioxins are disposed of with a special filter. On this dioxin filter, they are split into elemental components with the aid of catalytic oxidization, that is water, carbon dioxide and hydrogen chloride. Oxidation takes place in a layer of woven filter with a filter area of 1,800 square meters. The remaining gas oxides are cleaned from the incinerator by the so-called wet process. For this, the flue gas washer is used, which has 3 stages. The first stage is quench. This cools the hot flue gases to around 65 degrees C by spraying with technical water. The flue gases are saturated with water, which absorbs the largest proportion of the gaseous acids such as hydrogen chloride and hydrogen fluoride. Quench also condenses the gas oxides of metals, e.g. mercury. Deeper gaseous impurities, meanwhile, get into the operational water. In the second stage of flue gas washing, the absorption of carbon dioxide and sulfur trioxide takes place. The flue glasses are brought into contact with softened water, into which caustic soda is administered by regulation. The flue glasses rise from the bottom to the top, thereby filling up the washer against the current of technical water. This leads to a change of substances, and the sulfuric oxides removed from the combustion products have a pH of 6 in the technical water. The third stage of flue glass washing is the ring jet. This removes dust and aerosols, that is, the smallest particles. Following the third stage of wet cleaning, the flue glasses pass into the chimney. Their temperature upon exiting the washer is approximately 65 degrees C. The cleaned flue glasses are released through the operational chimney into the atmosphere. At the very end of the chimney, the gases are continuously measured. Upon failure of the washer or during a power cut, the flue glasses are automatically transferred to the so-called emergency chimney, which is permanently closed by automatically controlled flaps. At the same time, the incineration process is stopped, and for as long as is necessary, only flue glasses from the burning out waste in the incineration chamber are released. That is how flue glasses are released safely into the atmosphere during exceptional circumstances. Besides flue gas, waste incineration also produces cinders and slag. To stop raw cinders exhibiting their hazardous qualities, soluble salts and extractable heavy metals are removed from them. This is done with the aid of acidic water, which comes from the flue glass washer, more specifically from the first stage, that is the quench. Cinders stored in the silo after their removal from the flue glass are administered to a trio of extraction tanks. Here they are infused in water with pH 3.5 and a temperature of 65 degrees centigrade. Next, they are brought for dehydrating on a vacuum filter belt. Cinders washed in this way are taken to the slag bunker, where they are mixed with slag. This does not exhibit dangerous characteristics. The resulting material is used in construction, e.g. for landscape cultivation. The qualities of this product are guaranteed by production in accordance with quality certificates. To be truly environmentally friendly, we still have to clean the water used in the wet cleaning of the flue glasses in the washer and infusing cinders. This acidic water flows into the treatment plant, which consists of 3 tanks. Lime milk, hydrochloric acid and other chemicals are gradually added to the water. At pH 9.5, heavy metals are excluded and settle into a fine slurry of flakes. This slurry settles in the sedimentation tank, from where now clear water flows to the final control point. This is the last stop before it enters the sewage system. The slurry is washed and dehydrated in a candle filter until it turns to solid waste, so-called filter cake. This is collected in special containers and taken for solidification, after which it is stored at a landfill for hazardous waste. Besides producing building materials from slag and cinders, so-called sprukku, a large quantity of iron also leaves the incinerator. This is separated from the slag. Thanks to equipment for separating iron, up to 75% of metals found in the slag is captured annually. In this way, up to 4 tons of iron can be extracted from 100 tons of raw ash. Another environmental benefit is the fact that the energetic use of waste saves primary resources. Heat production in the incinerator limits production using other energy resources, and in the case of Liberec, this means savings of 17,000 to 20,000 tons of heavy fuel oil every year. This is not only beneficial for the environment, but for inhabitants as well. The operation of Liberec incinerator is complicated, and we hope that we have managed to explain the system as clearly as possible. We do not destroy the environment in which we live. Let us strive to use apparently useless waste for our benefit. Our children will surely appreciate it in the future.